Thanks everybody. Thanks for the opportunity to be here and to see so many people come along to this conference. It's really great. And I'd also like to acknowledge Carlin Research Office in Tyndall, who nominated me to present today. It's really appreciated for the opportunity. And also to acknowledge Salin Office for Research. I've been a member of HREC there for many years now, and it's been a real great privilege to be involved with that. So just to kind of follow on from the previous two speakers, and also thank you to previous speakers for their presentations, I wanted to talk a little bit more about some of the observations I've had working in HRECs for a number of years now, particularly with what we're seeing with all the changes related to AI. So I've got a bit of a presentation just to share some of my observations over the past several years and the changes that have happened, and some suggestions for how HRECs may start to prepare and adapt to the changing situations. So I'll introduce hold on one second. Here we go. So I'll just introduce myself very quickly. So my background's in mathematics, statistics, software development, and health systems. I've been really fortunate to work here in South Australia for a number of years now. I've had roles with Flinders University and SAHMRI since about 2012. And in 2019, we and a few colleagues decided to form a small startup, which has been a really interesting journey for us. I'll talk more about some of the work we do in just a moment. In terms of our experience, or my experience with HREC, I've been involved with two HRECs here in South Australia, with the Southern Adelaide Clinical Human Research Ethics Committee, SAHREC, since 2017. And I've been really fortunate to be invited to join the Carlin HREC, which is the Central Adelaide Local Health Network HREC, this year. I typically provide subject matter expertise for data, digital, and analytics, and it's been quite interesting to see that role change over time. I think probably when I first started back in 2017, a lot of the requests we were having were much more focused on statistical analyses and clinical trial designs and those kind of things. And now we're really seeing this change to large-scale data projects, really kind of integrated software devices, and of course what we're seeing with AI. In terms of hard AI, I've had a really great opportunity about 4 years ago to form a small startup here in South Australia, and we do a lot of really interesting work with SA Health. I won't go over too much about our work, but what we really do is we provide a lot of real-time clinical decision support systems, information systems. We do a lot of kind of data integration here in SA, and we've been quite fortunate to build a relationship with SA Health over the last 10 years or so. Particularly in the last 5 years, we've been fortunate to have a cloud environment deployed inside SA Health, and that environment has been classified to work with sensitive information that has really required us to go through a huge amount of process with making sure that environment is secure and well managed and compliant with laws and policies. And now we've got a major project that we are doing with Carlin, which is the top diagram over there. This is an information system that we deploy in critical care context. So we do real-time monitoring of patients in ICU wards and critical care wards. That's involved a lot of integration of data and a lot of software really needed to make those systems work. That project is approved by Carlin HREC, which has been a bit of a process for us to go through. Also, one of those projects that's a little bit unorthodox and a bit new. Some of these kind of new kind of projects we're seeing. The bottom figure there is a dose optimization tool for therapeutic dosing of vancomycin, which is one that we're developing at the moment. So we're kind of doing work in a bit of areas, but really focused on clinical areas at the moment. It's really interesting to hear Peter's talk previously. One of the things that we were considering is whether these two devices would be classified as medical devices, as software as medical devices. And I think certainly the bottom one, which we're developing at the moment, which does have a direct impact on patient care and kind of looking at different prognosis of patients, is probably a clinical device. Whereas the top one is it's more of a digitization of a paper record. And I did see in the previous talk that there was this exemption around digitization of paper records. And it's just been quite interesting to see for us, where do these become medical devices and where are they exempt? And our software is actually changing all the time, and there's different components of those software. So it has been a bit, again, convoluted to see which parts are medical devices or not, but it's certainly something I'm looking to know more about. So just a bit of an overview of this presentation. I'll try to get through this in probably about the next 15 minutes or so to leave a bit of time for questions. So I'll just talk very briefly about what I see the current situation as in terms of what we're doing with HRECs, where the real opportunities of AI is, and some of the changes that I think are happening to research projects. We're getting a lot more of these different kind of research projects coming through HRECs at the moment. I'll talk a little bit about AI guidelines and where they fit, and I think I really see three different kind of key areas at the moment. One of these is HRECs itself, so really kind of where do the ethical review process sit. But I think we also have to be aware of digital systems policy and other kind of operating models that exist in areas that we work. And in South Australia and certainly nationally, there are cybersecurity laws and policies that apply to us. There are patient privacy laws that apply to us, and there are certainly kind of data sensitivity laws that apply. And there's this interesting relationship between those and HREC processes. And I think I am seeing a bit of a disconnection between those processes. And for example, are HRECs responsible for cybersecurity? Like where do we actually draw the boundaries between these different organizational functions? So I'll discuss that a little bit. And also to talk a bit about project level governance. So actually on the ground, who has oversight over these systems, who's really responsible for AI projects, and reflecting on other things such as the relationship to things such as data safety monitoring boards. I'll talk a bit about specific guidelines, some areas that I've seen, different areas of change in HREC, so different kind of research projects that are coming through, how we deal with massive amounts of data that we're seeing now, kind of massive integrations of data. What does this mean for things such as statistical power analysis? Now, this is quite curious because I think these days people aren't quite sure how to apply power analyses to AI projects, and there are ways to do it, but I think it's evolving so rapidly that we've kind of got a bit of a misalignment to what this means with power analysis and research design. I'll talk a little bit about actually implementing AI. So some of these projects that are coming through are trying to implement AI in practice, and there are particular considerations for those projects as well. I'll touch briefly on causality and bias. This is certainly something where if we're looking at what is the AI actually doing, is it understood or is it a black box? It really does talk a lot about kind of the safety of these mechanisms. And then I'll conclude with some brief recommendations and certainly some acknowledgements for our supporters. In terms of areas where I think there's a lot of opportunity for AI at the moment, as the previous two speakers talked about directly and indirectly, there's really the landscape's changing so rapidly at the moment. And I think anybody that's going to work across any of these and other areas has kind of seen where AI could have an impact. It's really just, it's appearing everywhere. And I'm really kind of seeing this along the bench to the bedside, these different areas where AI is popping up. Areas that I mostly work in are more towards the clinical end, so I do a lot of work in predictive analytics and clinical decision support systems and those kind of areas. But we're also seeing this in areas such as drug discovery and kind of looking at drug effectiveness and epidemiology studies and these kind of things as well. So I think AI, and particularly the accessibility of AI, means that a lot of these areas are becoming a lot more achievable. We're actually seeing researchers who may not actually be experts in AI are starting to use AI as part of their projects. And it is putting a lot of pressure, I think, on HRECs to meet both the demand in terms of the quantity of projects coming through, but also the kind of complexities that are coming through, and some things that I'll talk about shortly. So what's really kind of happened over the last 5 years or so, or certainly kind of in the last year or 2 years with ChatGPT and some of the LLMs and some of those other kind of models coming through? I think we're seeing certainly greater accessibility with AI methods. We are seeing that a hobbyist researcher or a researcher that may have domain expertise in the clinical setting or in a drug discovery setting now can use AI as part of their research projects. And these kind of AI methods are much more readily available. They can purchase these or use these off the shelf. Sometimes they're open source and free, and you can kind of use them in a day or 2 days. And so we are seeing this ability to use them quickly, but using them well is certainly a bit of a challenge that we need to be aware of as well. Data is being accessed at a huge scale currently. So 10 years ago, it was quite difficult to get data, or you really had to know the right person or which kind of processes to go through. But now I think more and more we are seeing the breadth and depth of data being much more widely available. We're seeing changes in complexity of these systems as well. So particularly with an AI system, we're not talking about potentially just an analysis on one data set. We may have multiple data sets and multiple moving parts and interactions from multiple systems. And this does kind of lead us to how we make sure that these systems are actually well managed. And we're seeing both more people and different kinds of expertise of people that want to use these kind of systems. And of course, there's a huge national push at the moment to build up capacity in artificial intelligence. So government and industry are investing heavily in these. So it's really good. And overall, this does lead us to the potential of actually improving patient care and practice. But what does this mean for HRECs? Well, I think a few things that I've certainly observed. The guidelines that we currently have are good. They do look at things such as general risk, general benefits to the patients, things that we should kind of consider. But I think they are becoming potentially increasingly out of touch with what we need to be aware of with dealing with complex AI projects and what things we should actually be looking for when assessing these projects. And certainly we're seeing a greater number, just a sheer kind of number of projects that are coming through. I do sit on two of the largest HRECs here in South Australia currently, and there's a huge amount. I'd say every time we have a session, there's maybe 20 to 40% of projects are artificial intelligence have got some kind of analytics involved with them. So it's putting a really great burden on HRECs to be able to meet the demand. And I think it also talks about what kind of expertise we need to have on HRECs to be able to meet that kind of demand as well, particularly cross-disciplinary expertise as well. One thing I really want to highlight in this talk is what I'm seeing as a disconnection between the responsibility of HRECs and also what we need to do in terms of laws and policies that apply to these projects, even if they're not strictly the responsibility of HRECs. These are things such as cybersecurity or data sensitivity or patient privacy. These are things that apply to these projects implicitly, but they may not be part of a formal HREC review process. So where does that sit in terms of HREC needing to kind of make sure these are compliant, even if that is the role of HREC, for example? So I'll just talk about what I see in terms of ethics, in terms of digital policy, and in terms of project level governance very briefly. I think we're certainly all aware of our responsibility in terms of ethical review process. We've got the gospel, the national statement on the right over there, which is a really great, just kind of relatively succinct document that talks about these things at a broad level, but certainly is a great guiding framework for us to follow the path with. In terms of ethics processes itself, probably what I would like to see more of is more expert representation on HRECs. And I think different kinds of expert representation. So I do sit on those two major HRECs, but there are different kinds of expertise that I'll also talk about a little bit further. So, for example, I have expertise in areas of digital systems and of using AI on the ground and actually kind of like operational AI. But there's areas of AI that I don't have a great amount of expertise in, such as medical images or drug discovery. And I think HRECs do need to look at what kind of skills, like what kind of expertise they need in terms of being able to meet these projects that are coming through. So I think there should be a greater level of awareness of that. In terms of digital systems policy, much more generally, well, I think these things do apply implicitly to these projects, and some of the things that I've listed there, some of those dot points are things that should apply to these projects. My suggestion is that HREC should certainly be aware of when these kind of policies apply and should potentially consider whether to take a level of responsibility. And Peter previously talked about regulation and where regulation actually applies in terms of TGA. And that was something I didn't know, was that HRECs do have a responsibility to actually to consider regulation as part of their review process. So I wasn't actually aware that HRECs had a responsibility for that. And I would say there should be a level of responsibility of HRECs with some of these greater digital systems policy as well. One of the great reference frameworks that I think is probably the best reference framework in Australia, just based on my limited exposure, is the New South Wales Government Artificial Intelligence Assurance Framework, which I've shown here on the right. I think that's probably one of the most authoritative resources at the moment. I was really fortunate to go over to Sydney in September this year to meet with government representatives around Australia and with New South Wales Chief Data Scientist Ian Opperman to go over the AI assurance framework. And I think it's an amazing resource, and I would encourage everybody to have a look through it. Here's an example of the framework here. So just an overview on the left and some references that are cited in the AI assurance framework. And you can see it's quite comprehensive. They really cover a lot of the international standards. So I think just in terms of a bit of an authoritative reference for how we should look at AI projects, this is certainly a good resource. And I'll be really happy to work with anybody in the audience to actually look at this and how frameworks such as this would actually be applicable to the ethics review process. In terms of project level governance, I think one thing that we've typically seen, particularly with clinical trials and projects involving data, is a level of trying to encourage people to use to put up things such as clinical trials, like monitoring boards and data safety monitoring boards, and these kind of things, that when these projects are being run, we have a level of oversight from people that have governance responsibility over these projects, with AI, I think I'm not fully seeing this at the moment. There are certainly still in kind of running clinical trials in these complementary governance committees. But at the moment, in terms of things such as specific AI expertise, these may not be represented. And the project that Don mentioned to Peter previously about the gambling chatbot, this is a really good one. So who on that particular project actually has a governance responsibility to see that the AI chatbot, the gambling chatbot, is actually working as expected and is behaving well, or perhaps behaving abnormally, and what happens when it does go wrong. The clinicians are doing a really good job just to make sure that the patients or the participants are being treated correctly and to have their concerns raised, but it doesn't talk perhaps to the technical need to actually have an AI expert on a project level governance board. And of course, we've got the clinical decision support software there as well, which I wasn't sure who's actually responsible for that, but it's really good for Peter in the previous presentation to provide a bit of clarity around who should also have a level of responsibility to enact those regulations. So sorry, I've got a lot of dot points over the next few slides, and I see I have talked a bit over the past previous, so I'll go over these relatively quickly, but I think I've got some really interesting points here. So just in terms of particular kinds of research projects, there are a lot of different kinds of research projects. I'll just kind of highlight three different kinds that I think I see often. So these are AI software that comes on an existing data set. So there's probably some data set that exists inside the jurisdiction that you're working with at the moment, and researchers want to apply AI to that data set. Sometimes they have an existing AI solution and they want to apply it to a new data set. This happens very often when there's international AI software that they want to bring in and deploy locally. So it's kind of got this import of an AI technology. And probably the third, which is I think the one that should have the most scrutiny, is when we're actually deploying AI software in practice, it's actually using AI in a clinical trial. So I'll just say with these, probably the areas that I'll raise the most emphasis on is just making sure that we have a clear methodology for AI with these kind of projects. Probably what I've seen happen is a lot of these projects are not necessarily well understood by HRECs, and there's a lot of, I'd just say directly, de facto approval of these projects. So I think HRECs may not fully understand them, and because of our inability to have expert capacity to go through them, they tend to favour approving them. And I think another challenge that comes along with this is this designation of low negligible risk for these projects. I think that's quite a risky move, particularly if these projects involve working with a large amount of data. I think what I'll talk about shortly is that these projects, even if they may not directly involve interaction with participants, may have other kinds of risks, such as data breaches or developing models that may be potentially pathological. In terms of those data sets themselves, certainly over the last 5 years, we've seen this progression from small scale 100,000 sample size data sets, which are typically used for more of a like a drug discovery or a stage, like a phased clinical trial, or potentially something such as a statistical analysis, is now going to large scale amounts of data. And I'd say even here locally in SA, I've seen ethics projects being raised with access to hundreds of millions of data points for large scale AI projects. And in a way, there's a level of security that we can put around these projects in terms of de-identifying data, or for example, requiring the users of that data to go into a secure environment, such as either going on site or using something like Shore or some of the new research environments that are coming out. But I think we also need to be really cautious of normalizing an attitude that de-identified data is safe by default, because we're starting to see, particularly with what we can do with some of these more modern methods, is that we can re-identify these data sets, or we can create or detect patterns in these data, even if we think they're safe. So one thing I'd really encourage is both looking at who is responsible for data, who's the data custodian for that data, but also what is the operating model by which the researcher is interacting with that data. I think we have to move past the days of researchers extracting large amounts of data onto a device, even if it's a managed device, it's a device, a government device, or an institutional device. We're seeing this happen hundreds of times, kind of this duplication of data extraction. It's probably okay if it's small, but as the data does become into the millions and hundreds of millions of data points, and as that happens hundreds of times, the risk of that data being re-identifiable or becoming unmanaged increases exponentially as well. So I just think we have to be really cautious of looking to see whether there are better operating models, such as secure research environments, or even things such as machine learning operational pipelines, some kind of more advanced things we can actually use. So I just kind of talk about one specific examples, just noting I'll probably just go through a couple more minutes. So there was, in 2016, there was this release of data that was done by federal government around some of the NDS PBS data, and I think they had about 2 billion lines of data. So federal made some of this data available. It was a de-identified data, and I think there was an approval process to be able to access this data, but there was still a huge amounts of data that was made available for those purposes. And a group of researchers at University of Melbourne set out to attempt to see whether they could re-identify the data. And they did this by looking at some of the data that was in the de-identified data set. These were things such as birth dates and kind of aggregated address areas and those kind of things as well. And sure enough, they were actually able to re-identify some really key figures in that data set. These included MPs, included like AFL players and those kind of things as well. And there was a huge amount of pushback when these researchers wanted to kind of raise their objections more publicly and actually draw a level of scrutiny on what was being done with this public data. And there was a huge kind of contestation about it. Eventually, that public data set was removed, but it just goes to show that thinking that de-identified data is kind of inherently safe is itself a risk. There are things we can do in terms of more advanced entropy-based measures and a whole range of kind of techniques we can do in terms of looking at how safe de-identified data is, but we have to do those techniques, or we have to ask that a researcher shows how safe the data is and not just use a catch-all term that de-identified data is safe. So that's just one particular example. I won't go through this one. This is just some of the work that we've been doing here in SA Health. This just shows how you can work with a secure environment. In this particular technical diagram, we do have an AI engineer that's actually able to deploy his model into a secure environment, train in a secure environment, and then get an aggregated report of that data at the end. So kind of developing this operational model where the researcher doesn't have to extract the data, they can actually bring their research into a secure environment. Statistical power analysis, I'll just summarize this very briefly. So I think what we've seen is that a lot of researchers, particularly those newer researchers that want to try their hand at AI, don't know how to use some of the more advanced techniques that can be done with statistical power analysis for AI projects. So there are techniques for AI, like complex AI, that allow you to detect, they do power the detection of an effect size, or allow you to show how much data you would need to power a particular model performance. So these do exist, but they are more complex to do as opposed to, say, your kind of standard statistical analysis. I think that doesn't discount the encouragement of those researchers to actually attempt to do some form of statistical power analysis. But at the very least, there should be some reference to external evidence bases, to some external references that they can actually justify how many patients they should work with, what their sample size should be. So what we want to avoid is this catch-all mechanism where researchers are just kind of saying they want to do an AI project and it's a bit of a fishing experiment. They want to see what they can find. I think that's just probably not good enough. I think we do need to have some justification for how much data and how it works. Again, apologies for the shortness of time. So just in terms of our implementation and safety, so for these projects that actually do get deployed in practice, there's additional scrutiny that goes into these projects. I think we do need a level of ongoing monitoring and kind of ongoing assessment of these projects, and this should be included in a research application. So if it's a project such as a gambling chatbot, how are we actually assessing that particular project over time in terms of how the AI is performing and what happens if the AI doesn't perform as expected? What's the kind of pathway for that? Very briefly, just to talk about causality, because I think a lot of people that want to use AI in terms of discovering some kind of effect or discovering some kind of form of driver of disease or driver of drug efficacy has to have some awareness of causality and bias. It's not as simple as it seems. So I think in a research application, we do need to have some justification for how they will test that something is actually meaningful or not. I did have a really nice story. I won't go through it, but we did this project a few years ago looking at patients presenting with chest pain to emergency departments. And we developed this model. And if you look in the top right over here, it says angiogram is actually the most informative thing for patients with chest pain presenting to emergency departments in terms of whether they had a heart attack or not. But those that have worked in a clinical setting before know that you typically only get indicated for an angiogram if you're already very likely to have had a heart attack. So what we're seeing here is that the inclusion of that particular parameter in that model is kind of like a fulfilling feedback loop. So by the fact that we've got angiogram in there, what you're really modeling is the fact that the doctors had made a decision that that patient's likely to have had a heart attack already. So you have to be very careful when you're actually doing the modeling, not to just use some automated method and think that the automated method is actually giving you some meaningful results. So a research application should talk about how it's actually going to determine which results are meaningful or not, and what kind of evaluation is going to be part of that. So I've just summarized some of my some of those thoughts over there as well. These are probably the ones that I think are the most meaningful, kind of the most prudent ones that we should be aware of as HRECs when assessing AI projects. We can certainly share these slides around after, and hopefully there's some things we should be aware of. If there is any members of the audience or greater members that want to actually talk about formalizing some HREC guidelines for AI, please let me know. I'd be very grateful to be involved in something like that. Please feel welcome to find out more about our work at our website, and a huge acknowledgement to our supporters and to our team that have really made this all possible. Thank you.
Oh my goodness, Lukah, that was just scary. It was a bit scary actually, but I think it's incredibly timely. As we're recording this, I think it should be mandatory viewing for all ethics committees, just to understand, I guess, the scale of the problem, because we, can be very casual about de-identification and re-identification. So in that regard, if someone is doing a study which is going to use AI and they say they've de-identified it, then clearly, as you're suggesting, the use of guidelines for HRECs would be really appropriate, so they know what questions to ask. But is it more the combination of what they're going to do, so large data sets plus AI versus large data sets and no AI? Is that clearly, I suppose the risk increases when you put all of those factors together. Would you agree?
Yeah, definitely. And I think one of the points I just had to glance over there is, I think one of the pathways I've seen work really well with HRECs locally is more of a stage progression. So AI can work on a massive data set and can find some potential patterns, but I think the researchers should make a level of should try to use a level of constraint. So perhaps think about, well, what is the kind of the minimum data set that I need? Can I work with a smaller data set to start off with? And can I include less breadth of that data? So can I actually identify ahead of time which are likely to be the most relevant parameters to include in that analysis? Yeah. Give that as an initial, say, a pilot approval for a project like that to see whether the method's safe and viable. And following that initial assessment, then do a subsequent research application to access data in a greater capacity. So I think we've got a few tools we can do to stage these projects and to reduce that risk. But that risk itself inherently, I think, is still increasing just as technology is increasing.
Yeah, and maybe just time for one or two quick questions, Lukah. With the recent amendments to the national statement to allow low-risk research to be assessed by low-risk institutional committees, lower risk, would you classify AI projects as generally greater than low risk, or high risk?
I think there is probably a question there about scale. I think I have seen some AI projects come through that are looking at a very compartmentalized data set with a very well prescribed methodology for that data. It's probably low risk if you're actually looking at small data and what you're doing is actually very clear. But I've also seen AI projects come through where they're looking at huge amounts of data, and there's a lot more catch-all methods. They want to try to discover something. They may not know ahead of time the specific thing they're looking for, other than one or more things could exist. And I think that increases the risk. I think it talks about both the scale and the kinds of data that you're working with and what you're looking to do with it, which is, of course, a bit of a very nebulous response. But I think in that statement, when we're actually looking at what do we call an AI project, that actually goes into, I think, how we should actually classify those projects. We should actually have some reference by which we say this is more or less risky, therefore it's going to be designated appropriately.
And I think there's a clear need for guidelines to assist in that regard. One final question. I'm just going to kill two birds with one stone here. With samples being accessed from tumour banks, what can researchers do to ensure they're not accidentally becoming identifiable? And also, if you get a previously data set made non-identifiable by data custodians, is that still safe from being re-identified?
Yeah, so I might answer that second part first. So it's a little bit interesting in that that talks a bit about who is responsible in the organization for a certain level of de-identification. And perhaps if the data custodians had that responsibility, you could basically say it's safe because it's been deemed safe by a responsible party, and maybe that is appropriate. I think it also there needs to be awareness of the different kinds of techniques that exist in terms of re-identification. So we've seen things such as not including rare diseases or patients from remote communities, some of these kind of techniques, but also now that we've got more ability to find re-identification through pattern recognition and those kind of things, we need to look at things like, well, what's the information topology? What do we know in terms of entropy? So that if we actually have multiple data sets working together, can they actually relink if we had multiple de-identified data sets, which is basically what the University of Melbourne team did. So that's one aspect, which is we can probably look at who's responsible for that, but we just need to make sure that that responsibility, even say for the data custodian, is being met as the technology changes, which is not necessarily a HREC question, but does talk to kind of safety more generally. In terms of the high throughput data, medical imaging, biobanks, those kind of things, it has a very similar kind of sentiment, because that data is actually incredibly rich. I mean, there's been studies showing that if you have a chest X-ray, you can identify whether it's a particular ethnicity, and you can kind of use that as a source of potential identification. There's probably a lot that goes in that in terms of secure data repositories, operating models, things that are a little bit more deep, but you can kind of see how those things could potentially come together.
Gosh, look, it does show that I'm very much a fan of having a data management plan for ethics committees, but I think an AI and data management plan really makes a perfect sense. And I will say that our next talk by Jason Pohl in the effective use of data session, we'll talk about the use of synthetic data, and as you have mentioned, sort of a vault repository where you can't take data out of, which seem to be very sensible approaches. Okay, look, I'm going to have to cut you off.